To begin converting patient rooms into an information technology computer server room, start with a detailed assessment and planning phase. Firstly, determine equipment loads. Calculate the power consumption of all IT equipment including servers, switches, routers, and storage devices. It's crucial to determine the maximum power draw under full load and peak operating conditions to avoid overloading the electrical systems. Consider future expansion needs and allow for additional capacity so the server room can accommodate more equipment later. Secondly, calculate cooling requirements. Estimate the heat load generated by the equipment. This can be done using manufacturers' datasheets which typically provide thermal output specifications or by using industry standard calculations. Convert the heat load to British thermal units per hour or watts to properly size the cooling system. Size the cooling system, for example, air conditioners or fans, to handle the heat load with sufficient redundancy. This means having more cooling capacity than immediately necessary to account for equipment failures or increased heat generation. Thirdly, determine electrical requirements. Determine the voltage and amperage requirements of all equipment. This information is usually found on the equipment's nameplate. Calculate the total power draw in kilowatts. This calculation will inform the sizing of electrical components. Size electrical panels, wiring, and circuit breakers to accommodate the load, and provide multiple circuits for redundancy. Multiple circuits ensure that a failure on one circuit does not shut down the entire server room. Fourthly, plan for redundancy and failover. Provide backup power sources such as an uninterruptible power supply, known as a UPS, or a generator to ensure continuous operation in case of power outages. The UPS provides short-term power to allow for a graceful shutdown or to give time for the generator to start. Implement fault-tolerant systems such as redundant servers or RAID storage, which stands for Redundant Array of Independent Disks, to prevent data loss or downtime. Fifthly, consider access and security. Ensure adequate access for maintenance and repairs. The room should be easily accessible to authorized personnel for routine maintenance and emergency repairs. Install security measures like access control systems or surveillance cameras to protect the equipment and data. Access control systems limit physical access to authorized personnel only. Ensure proper ventilation to remove heat and prevent condensation. Adequate ventilation prevents overheating and moisture buildup, both of which can damage equipment. Install fire detection and suppression systems to minimize risks. These systems can automatically detect and extinguish fires, minimizing damage to equipment and data. Ensure adequate lighting for visibility and safety. Proper lighting makes it easier to work in the server room and reduces the risk of accidents. Monitor temperature, humidity, and other environmental factors to ensure optimal operating conditions. Environmental monitoring systems can alert personnel to potential problems before they cause damage. Keep detailed records of all equipment, wiring, and configurations for future reference and troubleshooting. Accurate documentation is essential for maintaining and troubleshooting the server room. Consult with a qualified electrical engineer or data center specialist for professional guidance. These experts can provide valuable insights and ensure that the server room meets all applicable codes and standards. Use industry standards and best practices for server room design and operation. Adhering to industry standards ensures a reliable and efficient server room. Allow for future expansion and flexibility in the design. The server room should be designed to accommodate future growth and changing needs. Prioritize safety and security measures to protect the equipment and data. Safety and security should be paramount in the design and operation of the server room. When assessing power requirements, consider the following factors. Calculate the total power consumption by summing the wattage of all devices. Include servers, network equipment, storage arrays, and cooling systems. Account for peak demand, which is the maximum amount of power the equipment will draw under full load. This is typically higher than the average power consumption. Add a safety margin of at least 20% to the total power consumption to accommodate unexpected spikes of future expansion. This ensures that the power infrastructure is not overloaded. Determine the appropriate voltage for the equipment. In North America, common voltages are 120 volts and 208 volts. In Europe and other regions, 230 volts is common. Ensure that the power distribution system matches the voltage requirements of the equipment. Choose the appropriate type of power outlets and connectors. Standard outlets are suitable for most equipment, but high-density server racks may require specialized power distribution units. Power distribution units, known as PDU, provide multiple outlets and can monitor power consumption. Distribute the load evenly across multiple circuits to prevent overloading any single circuit. This ensures that a failure on one circuit does not take down the entire system. Use a three-phase power system for large server rooms. Three-phase power provides more efficient power distribution and can handle higher loads. Install a power monitoring system to track power consumption and identify potential problems. Power monitoring systems can provide real-time data on voltage, current, and power consumption. Use energy-efficient equipment to reduce power consumption and operating costs. Energy-efficient servers, storage devices, and cooling systems can significantly reduce energy bills. Consider using a power factor correction device to improve the efficiency of the power system. Power factor correction reduces the amount of reactive power in the system, which can lower energy costs. Implement a power management policy to reduce power consumption during off-peak IOs. This can include turning off unused equipment or reducing the clock speed of servers. When considering cooling, calculate the total heat load generated by the equipment. This can be done using the manufacturer's specifications or by measuring the temperature of the exhaust air. Convert the heat load to British thermal units per hour or watts. This is necessary to properly size the cooling system. Choose the appropriate type of cooling system. Options include air conditioning, liquid cooling, and free cooling. Air conditioning is the most common type of cooling system, but liquid cooling and free cooling can be more efficient in some situations. Size the cooling system to handle the heat load with sufficient redundancy. This means having more cooling capacity than immediately necessary to account for equipment failures or increased heat generation. Locate the cooling system in a well-ventilated area. This will improve the efficiency of the cooling system. Use a hot aisle/cold aisle configuration to improve cooling efficiency. This involves arranging the server racks so that the hot exhaust air from the servers is directed into a hot aisle, while the cool intake air is drawn from a cold aisle. Seal any openings in the server racks to prevent air leakage. This will improve the efficiency of the cooling system. Use a raised floor to distribute cool air under the server racks. This provides a more even distribution of cool air and can improve cooling efficiency. Install temperature and humidity sensors to monitor the environment. This will help to ensure that the equipment is operating within its specified temperature and humidity range. Use a building management system to control the cooling system. A building management system can automatically adjust the cooling system to maintain the desired temperature and humidity levels. Implement the cooling management policy to reduce cooling costs. This can include raising the temperature set point during off-peak hours or using a more efficient cooling system. Consider using a variable frequency drive to control the speed of the cooling fans. This can reduce energy consumption and noise levels. When planning for redundancy, provide backup power sources such as an uninterruptible power supply or a generator. The UPS provides short-term power to allow for a graceful shutdown or to give time for the generator to start. Implement fault-tolerant systems such as redundant servers or RAID storage. This will prevent data loss or downtime in the event of a hardware failure. Use redundant network connections to ensure that there is always a connection to the network. This can be done by using multiple network cards in each server and connecting them to different switches. Store backup data offsite to protect it from physical disasters. This will ensure that data can be recovered even if the server room is destroyed. Test the backup and recovery systems regularly to ensure that they are working properly. This will help to identify any problems before they cause a major outage. Develop a disaster recovery plan to outline the steps that will be taken in the event of a disaster. This plan should include procedures for restoring data, restarting servers, and notifying users. Keep the disaster recovery plan up to date and test it regularly. This will help to ensure that the organization is prepared for any type of disaster. Implement a change management process to control changes to the server room environment. This will help to prevent accidental outages caused by changes. Use a configuration management system to track the configuration of all servers and network devices. This will help to ensure that the servers are configured correctly and that there are no conflicts. Monitor the server room environment to detect potential problems early. This can be done by using a monitoring system to track temperature, humidity, power consumption, and other environmental factors. Use an intrusion detection system to detect unauthorized access to the server room. This will help to protect the equipment and data from theft or damage. Install security cameras to monitor the server room. This will provide a visual record of any activity in the server room. Limit physical access to the server room to authorized personnel only. This can be done by using access control systems. Store sensitive data in a secure location. This can be done by using encryption or by storing the data on a physically secure server. Implement a data loss prevention policy to prevent sensitive data from leaving the server room. This can be done by using software to monitor network traffic and block the transmission of sensitive data. Educate employees about security risks and how to protect the server room. This will help to prevent accidental security breaches. Perform regular security audits to identify and address any security vulnerabilities. This will help to ensure that the server room is secure. The steps for fire suppression are as follows. Install a fire detection system to detect fires early. This system should include smoke detectors and heat detectors. Install a fire suppression system to extinguish fires quickly. This system should be designed to protect the equipment in the server room without causing damage. Use a clean agent fire suppression system. Clean agent fire suppression systems use chemicals that are non-toxic and do not damage equipment. Ensure that the fire suppression system is properly maintained. The fire suppression system should be inspected and tested regularly to ensure that it is working properly. Train employees on how to use the fire suppression system. Employees should know how to activate the fire suppression system and what to do in the event of a fire. Store flammable materials in a safe location. Flammable material should be stored in a fire-resistant cabinet or room. Keep the server room clean and free of clutter. Clutter can increase the risk of fire. Develop a fire safety plan to outline the steps that will be taken in the event of a fire. This plan should include procedures for evacuating the server room and contacting the fire department. Keep the fire safety plan up to date and practice it regularly. This will help to ensure that employees are prepared for a fire. Consider the placement of computer room air conditioning units, often referred to as CRAC units, in relation to the heat load. Position the units to optimize airflow and ensure even cooling throughout the server room. The location of the CRAC units has a dramatic impact on the efficiency of the server room cooling system. Ensure that the units are located to maximize their cooling potential.